Hello everyone, welcome to today's session. Today we are diving to something powerful and essential in the world of data science and machine learning, which is linear regression. Okay, you just think this as a magic formula that helps us predict the future, whether it is forecasting sales or something house spring prices, even predicting the success of your next big idea, right? So linear regression is the foundation of it all. Okay, so by the end of this today's session, you'll be able to understand what exactly linear regression is all about. And one second, just keep going.
You only this one customer, I understand, they do have multiple hiring managers with whom you're talking, right? So, but I see the question of
Okay, build a simple linear regression model from scratch, and then we will proceed with exploring how to interpret the linear regression model output. So, training a machine learning model is not sufficient. You need to reuse the trained machine learning model to make a prediction about the new incident, new observations, or new events, or new customers profile, or something like that, right? And apart from this, you should be very good with interpreting the model output. Once you train the machine learning model, you can you should be good at interpreting the model's output also. Okay, it produces some output. Which one? The machine learning models. Okay, first of all, let us understand what exactly the linear regression algorithm is all about. As we discussed in the yesterday's session, linear regression is a supervised machine learning algorithm. So, okay, fine. What can we do with this? With that, we can solve the regression problem. Fine, we can solve the regression problem. What do you mean by regression problem? To predict the numeric variable, or to predict the continuous outcome variable. Okay, that is what the regression problem, that is what we discussed. So is there anything else we can get it by using the linear regression model? Yes, you can model the relationship between the dependent and independent variable. I told you in yesterday's session, if somebody says linear regression, so what things should come to your mind? Straight line, correct? If somebody says linear regression, the first thing which should come to your mind is straight line. I just draw it here quickly. This is your x-axis and this is your y-axis, and you just draw a straight line. This is a straight line. Okay, not the my hand is little bit shaking, and here this is y equal to beta naught plus beta 1 x plus c, or I just write it here, y is equal to beta naught plus beta 1 x plus e. So this is the equation for this one, the linear regression. Especially this line represents y hat is equal to beta naught hat and beta 1x. See, the actual equation is, this is the one for the simple linear regression algorithm, beta naught plus beta 1x plus e. This is the actual linear regression equation. Once you train your model, okay, and once you train your model with the historical data, your model is prediction ready, right? So then once you train your model, how it looks like this, the equation becomes something like this: y hat is equal to beta naught hat plus beta 1 hat into x plus e. So this is the predicted values. Okay, the predicted values lie on your straight line in the linear regressions straight line. Okay, number one is it is a supervised machine learning algorithm. Supervised machine learning algorithm. and using which we can fit a straight line. We can fit a straight line, okay? So why do we need to fit a straight line? What does it says exactly? So using the linear regression, you can model the relationship between the independent variable and then the dependent variable. Model the relationship between the independent and the dependent variable. I'm just using some abbreviation. Dep means dependent, indep means independent variable. Model the relationship between independent and dependent variable. Okay, that is the beauty of using linear regression algorithm. Okay, so now the question is, why do we have to use linear regression? To solve the regression problem, right? Because the relationship it models in a straight line relationship, because it models the, see, your x-axis your independent variable, right, and y-axis your dependent variable. So this straight line, okay, helps us to model the relationship between both the independent and dependent variable. Model the relationship between, that is what the third point it says. This straight line helps us to model the relationship between independent and dependent variable. Okay, what is the y? Y is the predicted value, which is nothing but the dependent variable, right? This is nothing but the dependent variable, or the predicted value. Predicted value or the dependent variable. And what is x? X is your independent variable. Got it? So y is your predicted value or dependent variable, x is your independent variable, and e is an error, and beta naught is the intercept, and beta 1 is the slope. Okay? Yes, it is recording it, don't worry. Okay, why linear regression is required? It is simple and interpretable, okay, and using which, right, so it is used to predict the future values. Apart from this, it is used to, so apart from this theoretical thing, right, the key objective of this one is predict the future values based on past data. I don't know why it puts line. Okay, so the linear regression algorithm is nothing but a supervised machine learning algorithm using which we can fit a straight line. So this straight line helps us to model the relationship between independent and dependent variable. And also it helps us to predict the future values based on the past data. And also it helps us to identify the relationship. Okay, so it helps us to understand how input variables are related to an outcome. As we discussed in yesterday's session, right? Does advertising spend really affect sales? 1 second. Someone joined now. So that's what, right? As we discussed on the yesterday session, the advertising spend and then sales, right? So it helps us to understand or reveals how input variables are related to an outcome. The classic example is, does advertising spend really affect the sales? We are spending money on the advertisement. How do we know whether that leads to increase in sales, right? So in the using linear regression, we can find out how the input variables in the sense the advertising spend is related to the increase in sales or affecting the sales. Okay, so often what we do, right, we use the linear regression as a baseline model or starting point before we try complex models. For example, you want to solve a regression problem. Let's say your manager told you to predict the sales. I want to build a predictive model which can help me to predict the sales based on various factors like ad spend in television, ad spend in radio mirchi, or ad spend in Instagram, Facebook, Google ads. We are spending money on different channels, ad channels, advertisement channels. Okay, I wanted to understand, whether spending money on the advertisement led to increase in sales. Question 1. Question 2 is, which advertisement channel helps me to boost my sales more? There is a saying, okay, there is a CEO of a company, I don't remember his name. So he was saying this one, he was having a concern like, I'm spending more money on advertisement. I'm not sure, which advertisement helps me to boost the sales more in my company. Spending more, but you do not know which one, helps you to boost your sales actually more, right? That is, if you do not know, then then your situation is not, you are not in a good position, isn't it? Then you do not know where to spend more, where to spend less. The simple example is, for example, you are spending more on the Instagram ads. That is the one actually, boosts more of your sales. But if you do not know this, and also you are spending money on Google advertisement. Okay, customers are calling you, hey, I saw your product in the advertisement. It's very impressive. The features, whatever you offer it, just want to explore it. I just called you. If everything is good, I'm okay to go ahead and sign up for your product or service, or I'm going to buy your product. As a CEO of a company, you are wondering, hey man, customers are calling me, and I don't know, right? How they got my number. I know how they, because we are, we are posting our banner, across the channels, but we do not know. When I ask the customer, he says, I don't remember, sir. I saw somewhere your advertisement. So hey, I wanted to understand, your service related terms and conditions, how much you charge. So in that case, you have no clue from which advertisement channel you are getting more revenue. So knowing that, what are you going to do? Can someone tell me? If you know a specific advertisement channel, that is the one contributing more to your sales, what are you going to do? Simple common sense question. You just think that you are a CEO of a company, startup company, okay? So for example, you are spending money on television ad, and then you are spending money on Facebook, and then Insta, and then you are spending money on Google ad, Instagram, Google ads, Facebook, television advertisement, and let's say you are spending in some newspaper also, right? Newspaper ad and flyers. Distributing notices to the public, by using some people's service. Okay, so these are the different modes of channels, different advertisement channels that you spend money to boost your sales. End of the day, you want your sales to go up. Okay, yes, you could see that the sales is going up, but you are not sure, right, which channel of the which ad channel boosts my sales. Why should I know about that? For example, if Instagram advertisement, right, that is the one gives me 80% of contributions in terms of boosting my sales, and the Google ad or newspaper ad, right, is just 5% only it gives me, or let's hypothetically say 60%, not 80%, 60%. A newspaper ad is 5%, flyer is just 2%, and Google ads maybe, right, so 10%, or let's say 10 percentage, and Facebook is 5 percentage, and TV ad is maybe right, so 15 percentage. Okay, so in this case the Instagram, right, that ad boosted your sales more compared to other ad channels. If I know this, what am I going to do now? If I know this very well, what I can do is, right, for example, I am spending let's say 15 percentage on television ad and 10 percentage on others. So next question is, okay, fine, 15 percentage of the revenue contribution comes from television ad, fine, the 10 percentage on here, and the next one is how much we are spending in TV ad and Google ad. Let's say in the Google ad you are spending more, but only 10 percentage of the contribution is coming from your Google ad. That means that only 10 percentage of conversion is happening compared to Instagram, right? So what you can do is you can, let's say hypothetically 20 percentage, okay, or 30 percentage money user. Google ads are so expensive, isn't it? 30 percentage you are spending here, okay. So in this case, what you can do is the cost is more, but the conversion is let's the 30 percent is in terms of cost, the amount that you spend, but the return is let's just 5 percentage of conversion. But whereas here 60 percentage of cost you spend here, but the the conversion is almost for 50 percentage. Okay, so 30 percentage here, and here, okay, maybe right, if you spend 60% of the cost, so even if you double it, what will happen, right? So 5 percentage, 10 percentage, it will become 10 percentage only. Obviously a simple math helps us to understand we are spending more money on Google, but the conversion is very less. But the Instagram we are spending we are spending more. Obviously we are spending, we are getting a reasonable amount of conversion than any other channel ad channels. So in that case, what you do, you cut down the cost on other channels, right? Instead of 15 percent, just spend 5 percentage, and probably you can spend 80 percentage on the Instagram. You can better plan where to invest more. This helps you to understand where to invest more. Otherwise, what will happen? You blindly investing more on Google ads. Let's say instead of let's say you are investing 60 percentage here, you are spending, where is that course? Okay, 60 percentage you are spending here, but the return is just 10 percentage conversion. So why should I spend 60 percentage here? Then we are wasting money, isn't it? Is it clear or not? Are you guys with me or not? Why should I spend 60% to get just 10 or 15 percentage conversion? The same thing, listen, I'm spending 60 percentage here, but I'm getting 50 percentage of conversion here. Okay, so in that case, right, better I can cut down my cost. Instead of 60%, probably 30 percentage, right? And remaining 30 percentage, you can put it 90 percentage. If you put it here, obviously, you can see more number of responses from the users. With a simple example, but is there any formula that is available to find out which advertisement led me to boost my sales more? Okay, so this is this is your independent variable. So these are all called your independent variable, right? You have something called ad spend or ad channel, and ad spend. Ad channel type, so something like TV ad, so how much you are spending it, but return you do not know where you are getting more, right? So is there any magic formula is available to find out which ad channel gives me a boost in my sales? No. So that's where the algorithm like linear regression really helps you a lot. Now the question is, to solve the regression problem, can I rely only on the linear regression algorithm? No, you have various other algorithms are available. So you have something called XGBoost. XGBoost is very popular, and because of its accuracy, and random forest is there, random forest algorithm. You can use these algorithms to solve the regression problem. And apart from this, you have something else called the support vector machine. support vector machine, you can solve both the regression as well as the classification problem. Support vector machine, you can use this algorithm. And the neural network, you have something called neural network. Likewise, different algorithms, you can use it to solve the regression problem. It doesn't mean only you have to use linear regression to solve the regression problem. There are alternatives are also available. Usually what we do is, even though we have an alternatives, we start using the linear regression algorithm as a baseline model. So linear regression algorithm is going to be a starting point before trying all the other algorithms. Is it clear? Fine. Next one is, now that you understood what is a linear regression is all about and why we have to use linear regression, and we understood what linear regression is nothing but supervised machine learning algorithm using which we can filter straight line. The straight line helps us to model the relationship between the independent and dependent variable, and also using linear regression, importantly, we can predict the future values based on the past data. So we discussed about two types of linear regression algorithm, two types of linear regression. So far we discussed only about the simple linear regression. One is simple linear regression, and second one is multiple linear regression. Simple linear regression. So simple linear regression in real world scenario, we don't use it, because in the case of simple linear regression, we'll be using only one independent variable, okay, to predict the dependent variable. In real world scenario, nowhere you are going to use this one, it is not going to be helpful. Okay, if you have only one independent variable, okay, you can use it. In that case, all you need to do is just use the simple linear regression. But in real world, you need more than one independent variable to predict your target outcome variable. Guys, do you think housing, to predict an housing price, can use only size of the house? No, right? If I simply say, hey, the housing price is dependent only on the size of the house, will you all agree with me? You will laugh at me. So yeah, not only the housing price is depending on the, one second, somebody logged out. Yeah, I admitted him. The housing price is depending not only on the size of the house, but also it depends on the age of the house. How old the house? Is it too older, or is it very less recently constructed one? Okay, what other factors? Likewise, right, in the real world, you will be using more than one independent variable to predict the target outcome variable. In our example, we are talking about housing price. Housing price, it requires more than one independent variable. Okay, that is what called as multiple linear regression. In the case of multiple linear regression, you will be using more than one independent variable, or the more than one features. Instead of saying independent variable, you can also use the term features. We can use more than one feature to predict the housing price. If you use more than one feature or the independent variable, that is called multiple linear regression. That's all, guys. Is it clear? Okay, can I predict only the housing price? No, you can forecast the salary, another use case, and you can estimate the medical cost. How much cost that I will be incurring it if I undergo for so and so treatment. You can estimate the medical cost, and importantly, right, the insurance company, the claims department, they can use the machine learning model or something like that. Let's say a customer is having the cashless insurance policy. For example, you are working with Cognizant, okay, they have a cashless insurance. If somebody in your family falls sick and they are not so well, you got admitted them in the hospital, and very first day, right, you go and tell your employee, that's all. They start doing it everything from their side without collecting any money from you. Maybe they collect a very small amount, they will start the treatment. But what the insurance company do, right, they get to know from the hospital what kind of disease, what kind of problem this patient has now, based on which they want to estimate the medical cost. If the medical cost is beyond, way beyond the insurance amount that you are eligible, right, sum assured, then they will intimate you. Okay, this is the what we can foresee for this specific treatment, since we can cover only this much. As an individual, you can also estimate the cost using linear regression, and apart from this, predict the exam score. How do we predict the exam score? How do you predict the exam score? Simple example. See, like housing price, you need to know the size of the house, correct? And you need to know the age of the house and the location of the house. When it comes to predicting the exam score, what other factors influences the exam score? Let me see how many of you can answer it. What factors influences the exam score? Simple example is hours of study. More the hours you spend, that's a common phenomenon. More the hours you spend, the more the knowledge you acquire, right? So more in depth you can understand the concepts. So that is one of the important factors, right? To predict the exam score. Okay, so these are the simple use cases. Apart from this, to predict the return on investment. So what are the factors that can influence my return on investment? Okay, so those are the real world examples, real world scenarios where we can use the linear regression algorithm. Apart from this, in the case of bank, for example, banks are giving loans to the customer. They can predict which customers are more likely to default. Okay, so customers are going to default based on their recent transaction, past transaction. The machine learning model helps them to understand, hey, so customers are going to default. Okay, if they don't make the payment, at all, how much money are we going to lose it? Is there any way that we can make a prediction? Here we wanted to predict how much loss are we going to incur in case of they don't make the payment at all. That kind of scenario also you can use the linear regression algorithm, correct? Because using linear regression you can predict the continuous outcome value, or you can predict the target outcome variable. Okay, so everything is fine. Now the question is, what is beta naught and beta 1? Y is equivalent to beta naught plus beta 1. This is the equation for simple linear regression. We'll start with understanding the idea of intercept and slope using a simple linear regression equation, and then we can evolve our understanding by using the multiple linear regression algorithm. So what is beta naught? I said beta naught is the intercept. And what is beta 1 is the slope. What is x? X is the size of the house. Size of the house in square feet. So what is y? Y is the housing price. Okay, I want to predict the housing price. Okay, so now y hat means predicted value. Okay, so what is beta naught and beta 1 x1? So let's the x is my size of the house, right? That's what I said. Let's say my size of the house is 500 square feet. Okay, I just plugged in some value in this equation. Okay, and if I know the value for the beta naught and beta 1, okay, if I plug in here, I can get the predicted value, isn't it? If I know the beta naught value and then beta 1 value, this is my beta naught and beta 1. So we don't have to worry about estimating the, so you listen very carefully. I did not use the term computing, okay? Estimating the value for the intercept and estimating the value for slope. Okay? Is it clear? So what exactly the intercept is all about? Visually, so the theoretically, if I draw a straight line like this, let's take so here you have the x-axis and y-axis. This is your housing price, and this is the size of the house. Okay, here the line which touches the y-axis, this is called your intercept, beta naught. Okay, fine. This is theoretically the line which touches the y-axis is called intercept. So I am a businessman. Okay, you tell me in terms of how it is going to be helpful in terms of understanding in dollars and money, or in terms of rupees. Here the housing price beta naught is tells us the housing price, the average housing price when the size is 0. So the beta naught is the average housing price when x equal to 0. Remember very clearly, this beta naught intercept in this case, in this example, it does not make any sense. For example, your x square feet is 0. That means I am not buying anything. If I don't buy anything, if you say the average house price is going to be 1 lakh, do you agree with that? Will you pay the money? No, right? So beta naught is, in this case, it is meaningless. But there are scenario, the beta naught is the intercept is helpful. What scenario? I give you the example, the ad spend and sales. Your shop is in the prime area already. If you give advertisement, it can boost your sales. It doesn't mean if you don't give any advertisement, you will not get any revenue, isn't it? Is that true? No, right? Even if you don't give advertisement, still the business customers are coming to your shop and they are buying it. Those people are living close by to your shop. They come and buy it still. Correct? Say yes or no. Yes. But if I give advertisement, so I get more number of customers visit to my shop. So the beta naught, what it tells us is the intercept, right? So sales is my y, right? So the y variable. So even if I don't give advertisement, which is x equal to 0, ad is 0, what will happen is still the sale is happening. That is what the beta naught. The average, in this case, housing price, right, when x equal to 0. Okay, here I just write that example also. Another example is this one. Sales and ad spend. And this is my x and this is my y. And in this case, my beta naught is 1,000 or 10,000. This is my beta naught plus my beta 1. Listen, my beta 1 is slope is 2. We don't have to worry. We got this number from the model itself. Okay, from this software package. Okay, this month I'm not going to spend any money on the advertisement. 2 into 0 is going to be 0, and the beta naught is the how much, 10,000. This is estimated by my model. That means in this case the intercept tells us when x equal to 0, when x equal to 0, when x equal to 0, what is the average sales we made? That is what intercept tells. So in this example, when x equal to 0, what is the average sales that that I can expect? So as per this, if you do x is equal to 0 means the ad spend equal to 0. You are not spending any money on the advertisement. In that case, the average sales is going to be 10,000. That is what my model estimated. So in the interview, they ask you what is beta naught. Beta naught is nothing but when the value of x equal to 0, what is the estimated average value of your y? Okay, next one is slope. So this is fine. Now you are pretty clear. If I don't spend anything on the x, right, beta naught, if I don't spend any money on the advertisement in this example, still I am going to get some revenue. So how do I interpret this? And when x equal to 0, the average sales, the estimated average sales is 10,000 in this example. Okay, I'm talking about this. Very good. So now the question is, okay, now you are clear about the you are clear about the intercept. Now you are clear about the intercept. What about the slope, beta 1? What about the slope? What is slope? What is slope? How much the housing price increases for how much the price. So price, okay, how much the housing price increases for each we can say this way, okay, for every 1 unit increase in square feet. This is the perfect statement. Okay, the slope helps us to understand how much the housing price for every unit increases in square feet. Or simple example is okay, let me just simplify or start with this statement. So the slope helps us to understand, right, how much or when x increases, how much y is increasing, how much y increases. We can say that way also. Okay, that is what slope. Yes, Priya, you are correct. Yeah, how much y changes for every 1 unit in increase in x. That's one way of saying that. So in other words, we can say it in a different way also, right? How much the value of y increases with respect to x. How much y increases with respect to x. How much, we can say the other way also, right? When x increases, 1 second, this is painful. Here I will write it. I just write it neatly, the slope. We can represent the slope in two different way. The one is how much y changes when with respect to x, with respect to x. We can see this way, or in a very granular level we can say this way. Okay, how much y changes for every unit, or every 1 unit, or every unit increase in x. Sometimes we may not be able to understand the theory part with the with this textual thing, right? Simply writing it. So only when we visualize it we will be able to understand. Look here, this makes your life very simple to understand this idea, right? So here this is what your housing price. Okay, your housing price is, let's you are let's say you want to buy 1,000 square feet. So in that case, how much, what is the price of this one? Okay, this is the size of the house. Exactly size. For example, it starts with, one means, just think, this is in terms of 1,000 unit or 1,000 square feet, okay? 1,000 square feet to 2,000 square feet and 3,000 square feet, something like that. So when the square feet is 1,000, the price is, let's 1 crore. Okay, so then you will put a dot here. When the square feet is 2,000, then it is going to be 2 crore. Okay, and then you put a dot here, and similarly you put a dot here, right? So and then when you connect these lines, that is what your straight line. In this case, we have modeled the relationship between size and price. As the size increases, the price also increases. Right? As the size increases, the price also increases. Fine, that is a common phenomenon. Obviously, when the size of the house increases, price also increases. What is so big deal about a linear regression algorithm here? The big, the key highlight of this algorithm is, for example, if I ask you a question, okay, 1,000 square feet is 1 crore, 2,000 square feet is 2 crore, 3,000 square feet is 3 crore, fine. What about 1,650 square feet? How much does it cost? If the square feet size is 1,650, okay, so in that case, look here, where is my cursor? Okay, here, let's approximately the 1.6 square feet falls in between here. Okay, 1 and 2 is right. This is 1,000 square feet, 2,000 square. This is my 1,600 square feet, somewhat here, right? And if you draw a straight line here, and then if you draw a straight line vertically and horizontally where it intersects this line, right? That is what the estimated housing price. So this is 1 crore. 1 crore is here, just above the 1 crore it is somewhere here, right? So this is the line. So 1.6 somewhat 1.4 crore or something like that. If you ask questions like this, what if this square feet size is going to be 1,820? How much the housing price is going to increase? What is the estimated housing price in that case? Yes, just by joining this line, you can get the predicted value, correct? So in that case, as a data scientist, what you do? So here, right? So here, 1.8. So you just draw a line here and here, and and then you are going to draw a line here and here. Wherever it intersects, that is going to be your price. Somewhere here, right? So 1.9 crore or something. The 1.850 crore. Okay, 1 crore 85 lakhs, something like that. Got it? So in this case, the slope actually helps us to understand how much the housing price is going to change when the value of x or the square feet increases. That is what slope is all about. So delta y, we use the notation delta y divided by delta x, right? So how much y is going to change when x is going to change. This is called your slope. You don't have to worry about slope. You don't have to manually calculate it. It is calculated by the model automatically. Okay, this is calculated automatically by the model. So are there any formula? Can I calculate it manually? Yes, you can calculate it manually also. There is a formula for calculating the slope manually. Okay, for beta 1 is the notation we use it for slope, right? For every okay, this is a sum of xi minus your x bar. So x bar means mean. Okay, if you find a line on top of it, that means mean of x. Okay, mean is average. In statistics, we use a term called mean. Mean means average. So and multiply this by yi minus y bar divided by sum of xi minus x bar whole squared. Someone already invented this one. Okay, they did the research and they came up with the formula for this slope. Let's not worry about this formula at this moment. First understand what exactly slope and what is a intercept. I just write intercept also here so that you can remember everything here. Okay, the intercept is nothing but the average, the estimated average value of y when x equal to 0. Very simple. This is intercept and this is the slope. Okay, first you need to understand. Once you are able to understand this one, then the rest of the things are pretty simple. Okay, like I said, right, look here, let's take the same example here. This example, y is equivalent to beta naught plus beta 1 x. Ignore about the error at this moment. And here the sales. Okay, let's take another example, sales, right? And the beta naught is computed by your model. You don't have to compute the the beta naught manually. And similarly, the beta 1, the slope. Okay, slope is nothing but the beta, and the beta 1 also estimated by model. I don't have to compute it manually. So that one is 6, right? Something like 6. That's all into your x x is your independent variable. Okay, so in this case, the ad spend. Okay, the x is the independent variable. Ad advertisement spend. So if I spend 500, 6 into 500, if I spend $500 in advertisement, how much, what is the estimated sales that I can get it? Okay, 10,000, right? So this is your intercept and this is a slope value. This is actual value of your amount, the advertisement spend or the amount spent. So 500 into 6, how much? 3,000, right? 3,000 plus 10,000, 13,000 sales you can expect it. You can expect. One second. Okay, and let's say my the sales is nothing but the y is equivalent to my beta naught is 10,000. This is my intercept value. This is computed by my my model. Okay, I don't have to compute it manually. And this is my 6. This is nothing but beta 1. Even this one also computed by model. And here let's $500. This is my ad spend. Okay, is it clear? So now if you solve this, whatever the value that is 3000 plus 10,000, 13,000, that is the estimated sales value. That is what the estimated sales value. Got it? So if you spend okay, if you spend, so what it says, right? If you spend $1, if you spend $1, your sales goes up by $6. This is 6. Okay, if you spend $1, we can say this way also. If you spend $1 or every $1, when you may spend every $1, your sales will goes up by $6. Okay, so here if I spend $500, so what is the estimated thing? Well, listen, if I spend $500, the estimated sales, right, which is going to be 13,000. This is my predicted value. Let's say your manager asks you, okay, hey, you are a data scientist, right? Guys, if I spend additional $1, how much am I going to get the sales? So 501 into 6, how much? So 501 into 6, 3006, right? So it is going to be increased by 6 rupees. If I spend $2, okay, it is going to be double, right? It's going to double it. So $3, obviously, right? So it is going to be triple. So if you spend every $1, your sales goes up by $6. This is how we need to interpret. Okay, now the question is, this is fine. The manual way of computing, how do I do that? That we can see it little later. First, understand the big picture. So now you understood, right? So what is the intuition behind linear regression algorithm? We can model the relationship between the input and output variable, or the independent variable and output variable, by fitting a straight line. I just refined my statement. So this is my prediction. So my equation, you know very well, y is equal to beta naught plus beta 1 x. This is my equation, linear regression equation, and this one is my prediction. To make a prediction, what we are doing is, what we need to know the beta naught and beta 1. Very simple, guys. If you know the beta naught and beta 1, you will get the predicted sales value. I just made it very, very simple now. Clear? என்னுடைய ஈக்குவேஷன் வந்து y ஈக்குவல் டு பீட்டா நாட் பீட்டா 1x தான். ஓகேவா? இதில் வந்து பீட்டா நாட் பீட்டா 1 வேல்யூ தெரிஞ்சிருச்சுன்னா, if I know the value of beta naught beta 1, so I can make a prediction, correct? இது எதுக்கு பெருசாக வந்து மெஷின் லேர்னிங் மாடல் எடுத்து ட்ரெயின் பண்ணோம், அது பண்ணோம்? that we have to do it. Only when you train the model, it will estimate the intercept value, the beta naught, and it will estimate the value for the slope on your behalf. It makes your life simple. That's all. Once you get the beta naught and beta 1 value, you're all set. You can make a prediction. Okay? Okay, now the question is, in this case it is fine. What if I have more than one independent variable? You have used only one independent variable. if I have more than one independent variable, so how it is going to be the same logic here, okay? But only thing is you are going to have additional input variable or features. You are going to have it in your equation. Okay, you are going to have an additional independent variable will be there in your equation, that's all. So in that case, right, yeah, correct. Yes, Priya, what is your doubt? 1 second. Okay, yeah, that's what I'm going to discuss. Okay, if I have more than input, more than one independent variable, how am I going to interpret this one? So in this case, my result, right, depended on just only one independent variable. But if I'm going to introduce, yes, I will just come to that. Our question is, so in this case, we have only one in input feature that used it, the independent variable add spend, only one independent variable, right? So what if I have more than one independent? Because the sales can be predicted based on more than one independent variable also, correct? So instead of sales, right, we will take the housing price example. Okay, the same housing price example. Housing price you want to predict the housing price, and your beta naught is something like let's take the same value 10,000, and the beta 1 is going to be 6, and square feet is 1000 square feet. So 1000 into 6, how much? 6000 plus 10,000, 16,000. Got it? So in this case, you are going to have the housing, sorry, this is your square feet. This is your square feet. Plus, you are going to have one more independent variable. For that independent, the slope value is different. So this is called your beta naught, sorry, beta 1, and this is beta 2, and this is your beta naught. Beta naught is intercept, and beta 1 is slope coefficient for the square feet variable. Okay, for each independent variable, the slope value will also be differing it. Okay, it need not to be same. Okay, so let's the second independent variable is age of the house. Age of the house is 10 years. Okay, 3 into 10, 30 plus 6,000. How much? 6,000 plus 3, how much? 63,000 plus 10,000. 73,000, sorry, 6,000 here. 6,000, yeah, 16,000 plus 30. Okay, 16,030. That is the estimated housing price. In this case, we have more than one independent variable. Here, this is your age of the house. This is square feet of the house. This is the age of the house. Okay, we have more than one independent variable is there, because you cannot predict the housing price just using only one independent variable or only one factor, which is nothing but the square feet. Multiple factors are required to estimate the housing price. So in this example, we have introduced one more independent variable, age of the house. Likewise, you can add more number of independent variables. Now the question is, how many number of independent variables? For that, you should be knowing the domain. Okay, the domain is really playing an important role in terms of understanding what features can, additional features can I include it. So in this case, the housing price can be influenced by how much the square feet, and how much square feet, or what is the square feet, and what is the age of the house, right? And these two maybe right. So these two are with the combination of these two, we are able to estimate the housing price. With the combination of square feet and age of the house, we are able to estimate the housing price. So this is called multiple linear regression. So far we discussed about simple linear regression. In the case of simple linear regression, you are going to use only one independent variable. But multiple linear regression, you are going to use more than one independent variables like square feet and age. These are two different independent variables. Using these two independent variables, we are able to estimating the housing price. Yes, Priya, the slope need not to be same for each independent variable. For example, here the square feet. That's a good question. For square feet, the slope value is 6, and for the age, the slope value is 3. Oh, what is your question? Okay. Yes. So once this value is computed, yeah, okay, our question is, and the beta 1 is 6. My model, machine learning model, linear regression model, estimated the value for beta 1 is 6, and for the beta 2, my model is, for the age of the house, my model estimated the coefficient of, which nothing but slope is 3. So this slope value 3 is, specific to age, and this slope value 6 is specific to your square feet. So we call this as a coefficient. Okay, so this also we call as a coefficient. So this 6 also a coefficient, but the value 6, the coefficient 6 is specific to square feet, and the coefficient value 3 is specific to age. So in other words, we say, right, something like this. So the age, the variable age is, the coefficient value is 3, and the square feet variable's coefficient value is 6. You can say that way also. Only the terms will confuse you initially. Once you understand that, you will be all right. அது மாதிரி தான் தோசையை எப்படி திருப்பி போட்டால் தானே கொஞ்சம் நல்லா வேகும் இல்லையா, அந்த மாதிரி தான். ஸோ ஒரே டேர்மை வந்து டிஃப்ரெண்ட்டாக எப்படி யூஸ் பண்ணுறதுன்னு தெரிஞ்சுக்கிட்டிங்கன்னா தென் யூ ஆர் ஆல் செட். எப்படி கொஷின் கேட்டாலும் இன்டர்வியூல யூ கேன் ஆன்சர் இட், அண்ட் ஈவன் டூரிங் த ஸ்டேட்டல் கால் யூ டோன்ட் ஹேவ் டு யூ டோன்ட் ஹேவ் டு bluff, ஆர் யூ டோன்ட் ஹேவ் டு பேனிக். இது எதுவும் ஒன்று சொல்கிறான், இது புரியலையே நம்மளுக்கு, இதுவும் ஒன்று தான். Okay, coefficient value nale beta naught, beta 1, both of them are called coefficients. Beta naught, beta 1, also intercept and slope renduthme they use the term called coefficients. Okay, so what is the value for coefficients now? So they are asking for beta naught and beta 1, beta 2, beta 3 in the case of multiple linear regression. Yeah, and the formula part we'll go the formula part little later. Okay, don't worry. Is this clear? As of now, how many of you are clear? So in the case of multiple linear regression, we are going to use more than one independent variable. With the combination of more than one independent variable, we are going to the estimating the housing price. But remember one thing very clearly: whatever the input features that you are going to use it. Here I just write this point very clearly. Yeah, for example, here your exact, this is very important. Okay, size of the house, and this is the price. This is your y-axis. Since we have used more than one independent variable, age of the house, and here the price of the house, y is equivalent to beta naught plus beta 1 x plus beta 2 x, and here the y is the price is now housing price. Okay, beta naught is already computed by my model. Beta 1 is 6, and x1, this is x1 and x2, sorry. Okay, x1 and x2. X1 in this case is square feet. Okay, square feet is 500 square feet. This is in terms of square feet, and plus the beta 2 is 3 into x2 is your age of the house. For example, age of the house is 5. Okay, so here the square feet is an independent variable, another independent age. We have used two independent variables to predict the housing price, but make sure that these two independent variables or the input features are correlating well with your price. Only if these two quantitative variables are correlating well, then including these two features in your model makes really sense. Otherwise, it doesn't make any sense. The simple example, right? So visually, when we look at it, it's called correlation, guys. Correlation. We use a notation called OR, correlation. Okay. So correlation, and here, if you see the size and price, as the size of the house increases, the price also increases. Correct? That's the common phenomenon. As the size of the house increases, the price also increases. Hence, right, there exists a correlation between these two independent variables. Sorry, these two, these two quantitative variables. These two there exists a linear, relationship exists between these two quantitative variables. Linear relationship சொல்லணும். You need to use this term. So ரெண்டுமே quantitative variable, sizeum priceum quantitative variable. So for both of them have linear relationship. Okay, ரெண்டு பேருக்குமே relationship இருக்கு, fine. So இது வந்து since the line goes up, we can say positive relationship சொல்றோம். Okay, fine. Similarly, right, as the age of the house increases, the price also increases? No, right? Here it decreases, man. So if you see, right, as the age of the house is 1, the price of the house is somewhere here. Okay, let's 1 crore irukku. So inga irukum. As the house age of the house is increasing it, other one decreasing it. Okay, as the age increases, the price decreases. The housing price is because of depreciation. Correct? Correcta இல்லையா? So price increase, the age of the house increases ஆக priceum decrease ஆகி போயிடுது அப்படின்னா, so does that mean there is no relationship exists between the price and age? No, still there exists a relationship between price and age. Okay, so this is called negative relationship. Negative relationship. This is called negative. As the price, as the size increases, age increases, the price decreases. It is also called inverse relationship. There exists an inverse relationship. Okay, fine. Supposing, right, you have something like a feature called in the x-axis and y-axis. So the y-axis, the price is there, and here you put something like a number of power points, number of switches in house. So as the number of switches in the house increases, power points increases, the price increases. என் வீட்டில் வந்து 50 பவர் பாயிண்ட்ஸ் வச்சுருக்கேன் சார். நீங்கள் எங்கே படுத்தாலும் பட்டன் சுவிட்சு இருக்கும், நீங்கள் வந்து ப்ளக் போட்டுங்க, என்ன ஒன்று உங்கள் லேப்டாப் கனெக்ட் பண்ணி படுத்துக்கலாம், உட்காந்து படுத்துக்கிட்டே வேலை பண்ணலாம். நிறைய பவர் பாயிண்ட்ஸ் வச்சுக்கிறேன் சொன்னால், யூ திங்க் பேஸ்ட் ஆன் அதனால் ப்ரைஸ் வந்து ஜாஸ்தி சொன்னால் ஒத்துக்குவீங்களா? ரைட், உன்னை யாரும் எவ்வளோ வைக்க சொன்னாங்க தான் கேட்போம் இல்லைங்களா? ஸோ இன் திஸ் கேஸ் த லைன் வில் பி ஃப்ளாட். That means there is no relationship exists between these two variables. So in the case என்ன பண்றது? So don't include this variable in your linear regression equation. Only include only size and age in your linear regression equation. Just because I have 20 input features are available or independent variables are available, blindly I cannot include all the 20 or 15 independent variables in my equation to make a prediction. What if I include this, the number of power points in my variable? What is going to happen? It is going to add noise. They use a term called noise. Noise தேவையில்லாம ஒரு எரர் மாதிரி இது. It's going to be, you are going to introduce some noise here. Okay, so hence, right, before you include the independent variables in your equation, linear regression equation, make sure that are there any correlation exists between the independent variable and then the output variable or the dependent variable. So in this case, the size and prices are correlating well, and even the age is also correlating well with my price. Hence, including the size and age in my linear regression equation makes sense. So now you understood what is correlation: positive correlation, negative correlation, and here there is no relationship, right? So when you see the flat, the ECG level, the patient எடுத்துன்னு போகிற அவசரமாக ஐசியூக்கு ECGயில் கனெக்ட் பண்ணுறாங்க, ஸ்டேட்டில் இருந்தால் என்ன அர்த்தம்? Patient is gone, right? So அதுதான் இங்கே. So here there is no relation, R equal to 0. This correlation, we use a notation called R. This so this value of R ranges between -1 to +1. So ideally, if the value of R is supposed to be closer to 1, the closer to 1, that means the relationship is so strong. Okay, next question is, okay, size and prices having a linear relationship, fine. So it is correlating well. This is my dependent variable, independent variable. Both the independent and dependent variable are correlating well, linearly correlating well, fine. How well it is correlating? Next question. Can you quantify that? You know very well, right? So Americans, they ask this question. நீங்கள் எந்த மீட்டிங்கில் போனாலும் பிஸ்னஸ் கால்ஸ்லாம் பார்த்தா, can you please quantify that என்னுவோம் இல்லையா? So how do you quantify the relationship between these two variables? For example, that's where there is another equation for correlation. Okay, correlation. அதுக்கு வந்து பார்த்தீங்கன்னாக்கா, let's the value is somewhat, you get 0.8. 0.8 is somewhat closer to 1. Hence the relationship is good. ரெண்டு பேர் ஃப்ரெண்டாக இருக்கிறாங்க. இவரும் எனக்கு ஒரு 4 ஃப்ரெண்ட்ஸ் இருக்காங்க. ஸோ 4 ஃப்ரெண்ட்ஸில் பார்க்கும்போது லெட்ஸ் நம்ம ஃப்ரெண்ட்ஸ் ஏபிசி இருக்காங்க. ஸோ ஏக்கும் பிக்கும் 4 பேர்கிட்ட எனக்கு ரிலேஷன்ஷிப், எல்லாருமே எனக்கு ஃப்ரெண்டுங்க தான். அதில் என்னன்னா, ஹவு க்ளோஸ் am I with all the friends, அதுதான் வந்து குவான்டிஃபை தி வேல்யூ ஃபார் தி காரலேஷன். 0.8னா இவன் என்னுடைய க்ளோஸ் ஃப்ரெண்டு, அவனும் 0.9 அவன் இவனை விட அவன் என்னோட பெஸ்ட் ஃப்ரெண்டு அப்படின்னு சொல்கிறான் இல்லையா? ஸோ டு குவான்டிஃபை தட் யூஸ் சம் ஃபார்முலா. ஸோ இன் திஸ் கேஸ் correlation, the notation is called R. Any value closer to 1 is good. Any value closer to 0 is there is no relationship exists between those two variables. Yeah, any value closer to -1, that means a negative, a negative relationship, right? So now that you understood what is correlation, only when the input and dependent variable correlates well, you need to include that in your linear regression model to make a prediction. In case of no relationship exists between these two variables. Okay, so then how do I find out this one? We usually find end of the day the number matters, right? 0.8 or 0.7 or 0.6. Or for example, if you compute the correlation between the two quantitative variable, the same example, right? Price, and let's take this example, price and the number of power points. Okay, when you find out the correlation between, there is an equation for that, right? With that equation, if you find out, it gives you 0. That means there is no relationship. With that, you can simply exclude the number of power points. Even for computing the correlation, we don't have to do it manually. We don't have to compute it manually. Everything gives you by the formula. With your package, okay, statistical software, package that gives you everything, okay. So what we look at, it's already 1:34. What we'll do, right? We will continue the session tomorrow also, the same time, if you are okay, right? We will continue the same time, and then we will explore all these things, on how to compute it manually, the correlation value and beta naught and beta 1. Okay, we'll do it tomorrow. And then we will take the same example and I'll walk you through it one more time. And also with that package, how we can find out the correlation value, how do we extract the correlation from the trained linear regression model? How do we extract the beta naught and beta 1 value alone from the trained model in the Python? We can see it tomorrow, okay? Hope all of you are following me, right? Yeah, today I gave little bit different examples, right? Yeah, so that's what it's not that every day I follow the same pattern for same topic, different approach that we use it. Yeah. So I don't go by books. Whatever comes to my mind, I literally go by that. Okay, based on the experience, I will just go ahead and do that. Okay. Yeah, we will take one real time scenario for this linear regression also. But don't worry, right? First, I will do right. What I will do is tomorrow I will give the demo, and I will give you one assignment. Okay, you just try to fit the model and tell me what is the accuracy, how to compute the accuracy of the model. See, training the model is fine. Once you train the model, you have to use it, isn't it? So once you use it, it will make a prediction, correct? So you can make a prediction, fine. So how well my model is predicting it correctly? Just because I train the model, that doesn't mean my model should always predict with a higher accuracy. My model predict the housing prices 1.2 crore, but actually, right when I sold it, I got 1 crore only. There is a in that case, it overestimated. Underestimation also possible, overestimation also possible. These two are dangerous things. Depends on the type of the use cases. To evaluate that, there are some metrics are available. We'll cover it that also in tomorrow's session. Okay. Yeah, tomorrow I'll give you the assignment. You give it a try on Sunday, okay? And then the Tuesday we'll continue the session. Fine. Any questions as of now? Yes, right. I good. I just stopped.